In the last video, I introduced you to sets and set notation. Now we're ready to move on to set operations. In the rectangle are 10 objects that I found in my yard, and by putting them inside the rectangle, I am declaring that this is the universe for this example, meaning only the elements inside the rectangle exist and should be considered. Now I've added a triangular rock outside the rectangle. Because it's outside the rectangle, it does not belong in the universe, and using the notation we learned before, I would write triangular rock is not an element of the universal set. I've taken my 10 elements out of the universe because now I want to start adding some organization to these items. I've drawn a circle around 4 of the objects that share something in common. They all grow on trees. And I put a capital A outside of the circle so that I can refer to these 4 objects as set A. I've added a second circle to my diagram now, and I've put 2 flower blooms inside of it, and I'm calling this set B the set of flower blooms. Now I've added the remaining 4 items to my picture. These items don't belong in set A because they can't be found growing on trees, and they don't belong in set B because set B contains flower blooms. They are part of the original 10 items that define this universe, so they are contained within the rectangle, but they are outside of the 2 set circles. And the last thing my picture needs is the symbol capital U in the lower right corner to indicate that this is the universe of all items. Now with this diagram, there's lots of things you could talk about as a teacher. You could talk about how A is a subset of the universe, how set B is a subset of the universe, how they're also both proper subsets of the universe. You can also introduce set operations, beginning with the complement, also known as the negation. The symbol for the complement is the apostrophe placed after the set letter name. And please notice the spelling of the word complement. It has 2 E's, unlike the complement like, hey, you look nice. Anyway, the complement of a set is simply the items that are part of the universe that are not elements of that set. So in this example, if set A consists of these 4 items that are grown on trees, and our original universe consisted of 10 items, there are 6 items in A complement: nest, rock, white flower, marigold flower, bolt, and seed packet. I don't include poor Mr. Triangle Rock in the complement of A because he's not part of the universe. Similarly, you should be able to name the elements of B complement, which would be the 8 elements you see on your screen. Alright, I've updated my picture. Look at my circles now compared to their original locations. A and B now have an area of overlap. I'm going to change the way my sets are defined. In set A, I'm going to put all the objects that are brown from my universe. Set A now contains a nest, a pine cone, a stick, and a rock. The rock was a little muddy, so I'm calling it brown. Set B I'm going to define as objects that are colors other than brown. So you can see I've put the remaining 6 objects in that circle. When I placed the 10 objects, I was careful not to put any into that oval region that the yellow circle and the red circle share. That's because since those 2 circles overlap, that region consists of elements that belong to both circle A and circle B. And if I were to put something in there, I would be saying that it's an object that is both brown and colors other than brown. But now look closely at this leaf. The stem is actually brown. And you're going to have that student in class who, if you were doing this activity, will say to you, but Miss Hiller, this one does have brown. So where does the leaf belong in this picture? Notice I've put it into that area of overlap. It is inside the red circle, so it is brown, and it's inside the yellow circle, so it has colors other than brown as well. The area of overlap where the leaf is located has a name. It is called the intersection of sets A and B. It's where those sets come together and share common elements. Here's how the same example would look in words. On the left are the members of set B, the objects that are colors other than brown. On the right are the brown objects that are part of set A. Notice the only item that's on both lists is the birch leaf. The symbol for the intersection of 2 sets is the upside down U. We read that A intersect B, and notice I've written that it's equal to the set containing only the birch leaf. I've added a diagram that shows the overlapped area of the 2 sets being shaded with horizontal lines to represent the intersection. There's one other set operation we haven't defined, and that's called the union of two sets. And as you might imagine, it involves uniting the two sets, joining all their elements together to form one bigger set. If you look at the diagram, all 10 of our original objects are contained within sets A and B, with one of them, the birch leaf, being in both. But when you list the union, you would only list the 10 distinct elements. You would not list the birch leaf twice, in other words. Here's a picture of the union of two sets. Notice the solid line goes all the way around the outside of both circles and contains all the objects from both sets. And that concludes your introduction to sets.